guys, welcome to Boredom again. My name is Srihari Murli and sorry for the inconvenience, we weren't able to upload recently. So we are going to be covering right now the ought to be known topics to be learned in Java. So now I'm going to be telling you about classes and objects, and if you haven't watched the first video yet, check the link in the description. So here we were about to talk about some ought to know topics in Java, right? So we will be talking now about classes and objects. Object is an entity, is a unique entity which contains the data and functions and attributes and all. And the class is the representation of different type of objects. It's like a blueprint, Now I'm gonna show you a real life example of both class and both objects. Come on. So see here, this is a car class. That means a car is a class, a simple car. From that class we have different objects like a green car, a red car, a blue car, and the different objects which has different attributes like color, and then the company which manufactures it, and the model name, and then on which it runs, and etc etc. And for example, even if you take like houses, there's a simple blueprint of a house in a colony, and with that blueprint we build exact houses. The houses which are built, each single house is an object. The blueprint which is used to build it is called the class. So guys, now we are going to talk about the four main pillars of object-oriented programming, that is abstraction, encapsulation, inheritance, and polymorphism. Yeah, data dynamic binding is also important, but in a lesser way. So come on guys, now we will go to abstraction. Abstraction meaning the background processes are being hidden from the user interface. For example, you, the source code writer, will be only knowing what you will be writing. The others who will be only using your program in the output won't be knowing what is happening in the background. For example, in the addition thingy, if you want to add two numbers, you give 2 plus 2, 4, but you don't know what happens in the background, what happens when you give the plus sign. That's the source code written by the developers. So yeah, that's abstraction. For example, in real life, this TV, with this manual you can be able to operate this TV, but however, while operating, while using the remote and all, you won't be knowing what is happening inside the TV for it to work. And then data encapsulation. Encapsulation is like, for example, the login validation process is hidden here. When you insert your card, it just asks your PIN number, and when the PIN number is checked and when it's correct, you can do your processes which you want to. And then inheritance is a highly advanced thing. Right now the definition is just enough. Inheritance is where one class inherits properties from another class so that it does not have to have the same code again. Yeah, for example, code reusability. You have for example a function which is used to add two numbers in a class, and then you need the same function in another class, so you don't need to type the same code again. You can just inherit this existing class function into the new class. And then polymorphism is basically like different copies of the same thing. So polymorphism will be later talking also in function overloading and all. So I'm going to be showing you some different split up pictures for all these things. So data encapsulation, see here, wrapping up the data and the function is wrapped up inside the class. When it can't be used directly in the external program area except through the function where you can call it via an object. So this is where data hiding comes in picture, where it is encapsulated. Security is where this comes in picture. So you can so when I said that Java is very secure, this explains it. And then inheritance, so this two-dimensional attributes, this is an existing class. So after 2D comes 3D, right? So this radius, length, breadth and all is being inherited from the 2D to the 3D class. And then for polymorphism, so graph is a single thing, it's a function. A graph is a single function. with that graph we have different statistics. For example, a pie graph and a bar graph and a histogram graph. So this is where you use a single function for more than one purpose. Different internal structures but the same external interface. That's how it works. And then dynamic binding. Dynamic binding is important but in a less way. Dynamic binding is where you bind the code and the function during the function call. For example, static binding is where when you run, before running itself, it first binds the code to the function, to the signature, it calls the function and then the thing happens. But during dynamic binding, it only happens during runtime, during the execution of the program. Static binding, it happens before itself. After static binding, you will get the program, but dynamic binding, it happens during the execution itself. So thank you guys for watching. Next video will be uploaded soon, and then in the next video we'll be going to talk about code itself. We are going to the code itself in the next video. Yeah, simple codes we'll be talking, and we'll be advancing very soon. Thank you for watching. Please like, share and subscribe, and don't forget to click the bell icon.